Hi and welcome back. So first thing to say in this video is if you're a stickler for dates and really want to know, Henry Moseley lived from 1887 until 1915. Sorry I didn't see where I had written that down on my notes before I started the video, but anyway, and Henry Moseley again was the guy that I guess, or the chemist that figured out that the best way to arrange the periodic table was by ascending atomic number, not by the ascending atomic mass. So anyway, just to clarify that, I guess really what I wanted to talk about in this video, the first thing I want to talk about is you might be a little bit confused, and I'll scroll down so you can see the whole table. One of the things I know I definitely found confusing when I first found the periodic table was I kind of thought, what is all this stuff? What's all of this block down here of the periodic table, or all of this? And essentially, one of the things I guess I do want to point out is all this is this is a section of the periodic table which could just fit in right here. So if I could have a periodic table, and I pulled up a copy of this on Google, I could have a periodic table that essentially looked like this, where we have, this is our group 1, and we'll eventually we'll start talking about this in terms of blocks, and more on that later. But if you see where we have these two columns, or two first groups, this is what we're going to call our S block. So that corresponds to these two groups right here. Then right after that, we have what we're eventually going to call the F block right next to it, which is all of this stuff down here, which was kind of the thing that I always wondered about. And we have the lanthanide and the actinide series, and they go pretty much all you can do, or all you have to do to figure out where they go on the periodic table is you would just insert them in right there. And then we have the D block, or the transition metal block, right here, which corresponds to this whole block right here. Then we have what we'll eventually call our P block, and we can see it right here on this periodic table and right here on this periodic table. So hopefully that might clear up a little bit of confusion for you. I know I was a little bit confused about that when I first saw the periodic table. So hopefully you realize that this, pretty much the only reason that it's printed like this is to make the periodic table easier to print. It just makes it easier to print on one page, and for you to be able to stick it into a textbook or hang on the wall or anything like that. So anyway, the next thing I want to do in this video, I'm going to clear that off. I want to talk about, there are a few groups of elements on the periodic table which have specific names. And the way, and again, one of the things that I mentioned in the last video, and it's something we're going to see again and again, is that the trends that we're going to mainly take notice of, or the trends that we're really going to be talking about in this video, all happen in terms of the groups. And specifically, so the groups going down, these vertical groups that we have. And specifically, we're mainly going to talk about them in what we'll call right now, and eventually we'll figure out why, we'll call the S block, which this is the S block. And then also we're going to talk about some specific groups over here in what we're going to eventually call the P block. So anyway, and actually I don't really need those two right there, so I'm going to clear them out. So the first thing we want to talk about is this group over here, all the way on the right. This group are called, or the elements in this group are called the noble gases. And the biggest thing, or the most noticeable trait about the noble gases is that they are incredibly inert, that they don't like to bond with any other elements at all. They don't like to form compounds. They don't form diatomic elements, or They don't like to bond, and they are incredibly non-reactive. So, if you put, one of the experiments that we did in my chemistry class was my chemistry professor put hydrogen and oxygen into a balloon and then held a candle close to the balloon, and it made this incredible explosion in the room. It was really pretty loud. And then he did the same thing with a balloon filled with helium, and pretty much nothing happened. The balloon popped, but aside from that, we didn't get any real reaction out of it. And it's partially, this doesn't, I guess, explain it right now, but that is a trait that's a trait that I shouldn't say it's unique to the noble gases, but it's one of the definitive traits, or it's one of the definitive traits of this entire group of elements over here, noble gases. And we'll actually talk a lot about this in the future, about how what a lot of these other elements want to do, and really it's almost all of these other elements want to do, is they want to have an electron configuration that looks a lot like these guys. Because these guys are so stable, because these guys don't want to react anymore, all of these other elements sort of want to get that type of electronic configuration. And if you don't understand that right now, don't worry about it. We'll definitely talk much more about that in the future. But for right now, I just want to, I guess, label some different groups for you. So I'm actually going to, let me erase that arrow so I'll have a bit more room to work. So we started out with this first group, and this is the noble gases all the way to the right. So the next group, which is just to the left of the noble gases, is this whole group right here that starts with fluorine. And this group is called the halogens. Halogens. And one of the, traits of the halogens is that they are extremely reactive. They are incredibly reactive. They react violently with other chemicals. They are, the antithesis of the noble gases, or not necessarily the antithesis, but the noble gases are inert and don't like to form compounds and don't like to react with other elements. However, the halogens, it's essentially, it's not impossible, but it's incredibly rare to find a single atom of any of the halogens. Like in nature, all of these, pretty much you don't see the halogens unless they are bonded to something else. And we'll definitely talk about why that is more in the future. But the important thing to realize right now is, first off, that this group right here, the name of this group is the halogens, and that they are incredibly reactive. They are very reactive, and you can kind of almost think about the reason why they're reactive is because they're really close to the noble gases, that they've got an electron configuration that looks almost exactly like an electron configuration of a noble gas. So you could say fluorine has an electron configuration that looks almost exactly like neon. So there's just a small change that fluorine has to go through to have at least an electron configuration that looks exactly like neon. So it really wants to make that change. So anyway, and we'll talk much more about the specifics of that in the future. But for right now, it's just important to realize that the halogens are incredibly reactive. That that's also their name. They're named the halogens in this group. So the next group that we're going to talk about is actually all the way over on the other side of the periodic table, and it's this group starting with hydrogen. And hydrogen is actually not necessarily considered. It's still part of. It's not actually. I think it's not necessarily considered part of this group. So it's pretty much everything below hydrogen. Hydrogen shares a lot of similar traits with these elements, but I don't think it's officially considered part of the group. But this group is called the Alkali Metals. And part of the reason I think hydrogen is excluded is that all of these other elements are metals. They're solid at room temperature, and they have all the other characteristics of a metal. They're conductive. They conduct electricity. They conduct heat. They're shiny. Hydrogen, however, hydrogen is a gas. Hydrogen is a gas at room temperature. But it's still, hydrogen does share a number of traits similar to these alkali metals. But I don't know if it's. I'll have to actually check on that. Maybe I'll post a little note on the next video I make to see whether or not hydrogen is actually considered part of this group. They are definitely all in the 1A group. I'm not too sure if hydrogen is considered an alkali metal. I'll have to check on that. But anyway, the alkali metals, again, all elements really want to have an electron configuration that is very similar to, or that's exactly like their nearest noble gas. And the alkali metals, they're just essentially, you can see, we'll talk more about this in depth in a future video, but they're really only one element or really one electron away from having a noble gas electron configuration. And because of that, the alkali metals are, again, they're extremely reactive. They, if you put one of the experiments or I guess demonstrations we had in my chemistry class was my professor took a piece of sodium. And you can even, it's interesting, you can cut solid sodium with a butter knife. And it's also interesting that sodium has to be stored in oil. If it's stored just out in the air, it immediately starts to react with particles in the air. It starts to tarnish. So it really wants to sodium, you could say, really wants to react with another element, or really wants to react with other things in the atmosphere. But anyway, what my professor did was he took a piece of sodium, cut it, and then dropped it into a beaker of water, or a flask full of water, and it caught fire. And it was really interesting to see. It's that, this piece of this element that is, it's right next to a noble gas, something that has an electron configuration very similar to neon again, and neon is very inert, so it's only one electron away from having a noble gas like configuration. So it really wants to react. It's an incredibly reactive element, and hopefully you're understanding this a little bit. The main thing to get here is just the concept. We're going to talk specifically about how sodium loses that electron, and specifically, what happens. The important thing to realize for right now is, just like the halogens and the noble gases, that this group is called the alkali metals, and that they are, again, incredibly reactive. They're incredibly reactive metals. The next group, which is right next to the alkali metals, is this group, starting with beryllium, going down to radium, and this is called, these are called the alkaline earth metals. And again, these metals are also incredibly reactive. They're not as reactive as the alkali metals in group 1A, and this by the way is group 2A. And we'll talk more about the groups in the future, but these alkaline earth metals aren't as reactive as the alkali metals, but they're still very reactive. They very much want to get to having a noble gas-like electron configuration. So they are going to react. They are going to form compounds. So anyway, I guess that might be it for this video. The main thing, just to, I guess, take away is mainly just the names of these different groups that I've pointed out. And these are, we'll talk more about. There are a few other names of different groups on the periodic table that we'll definitely get to at some point. But these are the main names of the different groups that at least you'll talk about in the first couple of weeks of chemistry. They're in all the way to the left of the periodic table. We have the alkali metals. They are very reactive. They are incredibly reactive. They're the most reactive metals. Right next to them, we have the alkaline earth metals, also very reactive, but not as reactive as the alkali metals. Then over on all the way on the right of the periodic table, we have the noble gases, and then just to the left of the noble gases, we have the halogens. So that's the important thing to take away from this video. So anyway, in the next video, we'll just keep talking about other traits on the periodic table. So thanks so much for watching, and I'll see you soon.